Today we're going to talk about chemical properties. How chemical properties is a situation where a new substance is created, where it is irreversible. We're going to talk about how reaction happens and depending on the environment, new substances are being created, and also how toxicity is an example of chemical reaction. Now, first of all, last week I talked about physical properties. Physical properties are what? These are properties where the identity of the matter is preserved. So for example, if I have a glass of water right here. If I have a glass of water and I put it in the freezer, the water will turn into ice. If I take the ice, put it on the counter again, the ice will melt and I will get water again. If it happens that I have a pot of water and I boil the water goes into vapor, and if I condense it, then I get back water again. So this idea of water, we always have the same identity. Identity is preserved. It may look different, it might feel different, but it's always the same matter. So here we talked about the three states of matter. There's an extra one we could talk if you're interested, and if you want to do so, put it in the comments below. Otherwise, this idea of physical properties, they are changes that happen, but it is reversible. So we can go from water to ice, ice to water, water to vapor, and then vapor to water and ice again, always keeping the identity of water. Now, today, we look at chemical properties. So chemical properties, what happens is that you have a new substance that is created. So when there's a new substance, that means that we can actually see something happening. So let's see if we can look at a few examples. So the first one, when we have a new substance, let's see. I'm going to do a few experiments, something that I had handy. So sometimes if your stomach is not doing very well, we have here what we call something to neutralize the acidity so we feel better. So here we have a capsule. I'm going to just take half. I think it's better. Now, if I was to take the Tums and put it in water and I put it down here, I would notice that I have a few bubbles being created. You don't even see it nicely. So here we have a situation where we have very little reaction to water. Not everything reacts to water. So for example, if I was to take this pen right here, plastic, rubber, metal, if you put it in the water, nothing happens. There's no reaction. However, if I am to take, okay, I had an Alka-Seltzer here earlier. Other people that don't feel too good, sometimes we can use an Alka-Seltzer. So here it is a tablet. So by the way, when I break it in half, it is still the same type of materials. So earlier we talked about physical properties, the fact that we take something and break it down in pieces, we still have the same materials. Now, if I take a quarter and I put it back in my glass of water, you will realize that we have at this time a new substance being created. Let's see if I can. So here you can see a gas is created. So that means here that there's a new substance. There is a chemical reaction happening right here. So here what's interesting is that you have some materials that react with water here. This is what we call a chemical reaction. So if you look at this one again, so you can see the bubbles. I cannot take the ingredients of the bubbles, which is carbon dioxide, put it back with what's inside the water and create again the matter that is the Alka-Seltzer, because it is something that is irreversible. Now this is reaction with water. Now I'm going to give you another example. So let's see. So we'll take another glass and I'm going to put some vinegar this time. So vinegar is considered an acid. So let's see what happens. So if we take my Tums of earlier, so I have my half the tablets from Tums and I put it in vinegar. We know that there was no reaction to water. But this one here, if I put it here and we wait a moment, what do we see? Oh, look at this. We see that there is a reaction that happened. So some materials react in some substances, but not in others. So this is Tums in acid. What would happen if I would take my seltzer? So I take 1/4 and I put it in acid. You realize that, oops, it is even more reactive in an acid than actual water. So here you could see that depending on the environment, we have different materials reacting to different environment. So here we had an example of reaction to the acid. Now, if you take this one right here, so this is a rod of copper. You could see that here I took some of the oxidization layer off, and you could see how light pink it is. Copper, when it's native, it is a pinkish, like a reddish coppery color. There you go. But when it's in contact with the air, oxygen reacts with the copper to create new substance. And here you even have something that is green. So you have a variety of new substances being created because the copper is in contact with air. And often it is in contact with oxygen. We call it an oxidization. When you have an oxidization, there is a chemical reaction. Now, when we have a reaction like this, when I send it, I will send this material. So you cannot get the copper again. You have to take a layer because this is an irreversible reaction. So reaction to air like this. Very nice. Another example here. So this is an old hammer I used to use in geology. You could see that iron is light gray. This one here turned rusty colors because rusting is an example of a reaction with oxygen. So the iron in contact with oxygen creates a new substance. And you know as well as me that if you have a piece of equipment, even a car that is rusting, you cannot get the car back the way it was originally. When it starts rusting, then you've got particles of iron and steel going away, and then it disintegrates because you cannot get the iron back from the rust. The reason? It is irreversible. Here's an example also for other type of discussion. So let's see. So here I have the symbol here from WEMIS, and it is called environment. You have to keep in mind that when you have some chemicals that you put in the environment, you can affect it, and often it can. You can find ways to minimize the concentration of the chemicals. Sometimes there's an increase in concentration, and it is detrimental to the environment. In some ways, being irreversible in time. Humans have used often the atmosphere and the water to dilute our pollution, but pollution is still there. Keeping in mind that if it happens, where is it? I had an example earlier. Oh, it's right here. If it happens, you go to the pharmacist and you go to the doctor prescribes some medicine, and then you take your medicine. That is great. Sometimes if you have a few pieces of few pills left, it's always important to take them and bring them back to the pharmacist, because you don't want to put them in, let's say, the toilet and flush it, or in the garbage, because those chemicals from those medicines end up in the environment and it is not good at all. So that's something to look into. And what happens is, in small quantity, it's not the end of the world. In large quantity, it is damageable. And that's the next one here. If we have this one here, the skull and the crossbow here, this is an example where if there's toxicity, that is an acute toxicity. So in contact of, so our body, if there's too much carbon monoxide in the atmosphere, it is hard for us. It can be fatal very quickly. It is toxic. So what it is that you have a chemical in high concentration, and it can be dangerous. So sometimes people are saying, what kind of chemicals could be toxic in our body? Well, if you take sugar, too much sugar can be detrimental. For example, if you take little kids after Halloween, they're 4 or 5, they eat too much candy. What happens? They start running around like there's no tomorrow. And then right after they crash and they have a low of energy. It's not good for our body. Another example of toxicity would be, let's see, this one, I had another example and I forget. Oh, what is it? Oh, alcohol. Alcohol is another example of how chemicals can be toxic to our body, preventing proper communications between neurons. So toxicity is a situation where we have a chemical reaction. Now, I know that the body will process chemicals. However, we always want to do what's best for our body. So let's see the next one about creating a new substance. Here's an example where you have a road cut. So they are trying to get a new road. Here we have rocks. So what do? We are using explosives and we are blasting the rocks. So here, if you have dynamite sticks that are about maybe this size, we are drilling holes, we put the dynamite stick, and then as a solid, once it explodes, it turns into gas. What happens? We have an expansion of matter, and as it expands, it has a lot of force. We have a breakage of the rocks. I have here a little, let's see, a few examples. There we go. So this one is from Centre de Formation Professionnelle. Here, let's see. Let's see if I can make it bigger. So we have here some rock that we need to blast. So here we have the first, it just shows that we have the first explosion. The first explosion is important because rocks need room to expand. So if I was to put, for example, one hole right here, and then I was to put explosive right in the middle, what will happen? It will explode and probably come out from the hole. However, if we put it where you have a variety of holes, you align your explosive, then you can blast something bigger. So let's see, there we go. And then you can blast much bigger pieces of rocks. This works for road cuts, but it works in mining as well. It takes a lot of skills to do so, and it is a great job for some. So this is this one right here. Let's see if I have another example. I forget now. No, this is the last example. How do we know that when something explodes, it is a chemical reaction? Because we have a new substance being created. We have the explosive, which is a solid, creating a gas, which is a new substance. And therefore, it is a chemical reaction. I cannot go back, take all the gas, and try to pressure them back into an explosive. Sometimes color is also an example that there's a chemical change that happened. So for example, if you decide to do some pancakes this morning, you're going to take some flour, milk, some eggs, maybe some salt. You're going to put them together. When you mix it, you start mixing the ingredient, but you still have the ingredients. Once you put them in a pan, what will happen? You have a liquidy paste. You put in the pan, it will turn into a solid. So here's an example of a chemical reaction. You cannot take a pancake and get the dough again and then the original ingredients. And then on top of that, if your pancake stays a little bit longer, then it will go from a beige to a brown. The change of color means there's a new substance. If you leave it too long, it will turn black and there's a new substance again, new color. Always keeping in mind that these are examples on how we know there is a chemical reaction. And there's one more I forgot. It is combustion. If you have a campfire and you have some wood and you burn the wood, what will happen? You have flames starting. The logs will turn into ash, and the ash is completely different than the original log. There's a change in composition, change in colors, change in size, change in everything that happens. However, I cannot take the ash and the carbon dioxide that was put in the atmosphere to try to get the log back. It doesn't work. So it is something to keep in mind. And as a last example, the best one is our body is a great environment for geochemistry. So that means that when you eat food, let's say you eat broccoli, It's going to go through the digestive system. And when you go to the washroom, your solid waste is no longer broccoli. It has a change of colors and it has a change in smell as well. But you can never get your broccoli back. So these are examples, and I think hopefully you have enjoyed this.